All right, welcome back. So this is going to be the second lesson in the rational expressions unit, where we will be looking at multiplying and dividing rational expressions. So we're going to this is going to be nothing new. We're going to be using the same ideas, same kind of strategies, plans of attack that we talked about in the previous lesson. Only difference is that we're going to have kind of more parts to simplify, which just leaves us with more possibility for mistakes. So we just want to make sure that we understand what is going on. So here's just an example. That's kind of weird. That we talked about yesterday, or sorry, not yesterday, but the last lesson, where we had to simplify this. Now notice, again, this part, right, this expression is completely simplified. Or sorry, let me retract that statement. I can't factor anything, but everything is multiplied together, which means that when everything is multiplied, right, just like you see here, right, and just like you see down here, then I can cancel, oh gosh, sorry, then I can cancel the common factors, which is essentially what I did here, right? I just showed it in kind of another step. So I only cancel when I have the same factors in the tops and the bottoms, which means that the whole expression needs to be factored. Then I look for the common factors that I can cancel from the tops and the bottoms. Okay, some students like to just cancel before they factor, which is like not really cool. Like say for example, I mean, please never ever do this like for real. But like, if I gave you like x plus 4 over x minus 3, some students will do this. They'll be like, oh, cool, see you later, x. And then they get 4 over negative 3. And it's like, no one ever showed you that. So you're just misinterpreting something else that was shown to you. Okay. So let's get started. Now, again, we're going to kind of ease ourselves into this, look at it from a simple perspective when we dealt with just numbers, and then move on. So here I have two fractions that are being multiplied. So again, you can kind of deal with this however you'd like. We can, if you remember, when I multiply fractions, right, I just multiply the tops together and the bottoms together. So 1 times 6 and 2 times 13. So if you want to, then we can just write this as 6 over 26. And then what we want to do is we want to try to reduce this fraction, which generally means, can I find a number that goes into both tops and bottoms? And if they're even, as both of these two numbers are, we can divide by 2. So what I'll get is 3 over 13. And I cannot reduce this any further, right? This is it. Okay? Part B is just illustrating the rule for when I divide fractions. So hopefully you remember what I do when I divide. So the first fraction stays the same, and then I change the sign to multiplication and then flip this fraction. So it's going to be 21 over 24. Okay. Now, if you want, what you can do is we can kind of use that same or the same kind of process where I can multiply. This is going to be 2 times 21 over 3 times 24. So again, you can then just multiply them through if you'd like. Or you can, like, for example, if you look, like I have 21 over 3, right? So what's 21 over 3? That just equals 7. So what I can actually do is, for my next step, I can just write 2 times 7 over 24. And then, I mean, if you want to, you can just, we get 2 times 7, which is 14 over 24. And then we also want to simplify these further. So I know I can divide both sides, sorry, not both sides, tops and bottoms by 2. So then we get 7 over 12. And I'm pretty sure this is as simplified as we get. Okay. So again, what we're doing is we're just, again, how do I reduce these fractions? Well, I divide by a common factor. Okay. So now let's just take a look at what happens when I start throwing variables in. So remember, when dividing by a fraction, again, just some highlights here, we want to find the reciprocal of the second fraction. And we multiply the first fraction by the reciprocal of the second. So here, if we look, we say, okay, check it out. So this is 2 over x times, notice sometimes we'll use a dot for times just so it doesn't confuse people with a variable or the multiplication sign. So we want to multiply this in state restrictions. So again, let's just write this out. So 2 over x times y over 2. Now again, we can multiply this out. So it's going to be 2 over y over 2 over x. And then hopefully you see that these 2's can cancel because 2 over 2 is 1. So I am left with y over x. And then now we need to state restrictions. So let's just check out where my denominator. Here's my denominator there. So the 2 doesn't have a variable with it. So 2 is 2 forever. Okay. However, the x here, obviously, right, x can't equal 0. So that's my restriction. So y over x, where x cannot equal 0. Okay. Everybody cool with that? All right, we're just going to take a little break, and I'll come back with the next part of the lesson.